design of this as I view to the left. Now, if and
Hello students, welcome to my YouTube channel VRacademy. We are here to study the digital electronics and today's topic of discussion is encoder. Okay, so we have completed various topics of combinational circuit. The last two topics are encoder and after this we'll have to go for decoder. So what exactly encoder is? So prior to going to the topic, I just want to interact with you as a layman if what is the meaning of encoder. As a layman you can say that the encoder is kind of device which will convert any type of given number to a particular code. So that is what a layman can say about this. But whenever we are talking about the digital electronics, then in that case you have to think that binary numbers are going to be playing the vital roles. So that means any kind of numbers or symbols has to be converted into binary codes. So the device which does this work, I mean converting any kind of numbers or symbols to binary codes is known as encoder. So when we are going for the definition of encoder, you have to remember that two concepts. The first concept is that it is a combinational circuit that have the conversion of any number system or any preferred symbol to binary codes. So that is what is written over here. It is a combinational circuit that converts any preferred number or symbol into a particular binary code. So that type of device is known as encoder. Now, basically what happens in case of encoder, a particular symbol we are giving as the input to the encoder and it will convert it into n number of binary codes or n number of binary outputs. So basically in case of encoder we can say that we are giving only one symbol as the input and we are getting n number of the outputs. So once again it will be quite matching up with your demultiplexer. If you can recall, there also we were having only one data input and we were getting many outputs. So here also in case of encoder we'll have one symbol as the input and we'll be coding it in the n number of binary codes. So many a times it comes as a questions in various examination that what is the difference or what is the similarity between encoder and demultiplexer. So all such type of question may come and you can have the comparison of these two. So with a proper comparison, are you be able to tell me the difference between a encoder and a demultiplexer? I want your answer should be given in the comment box that what is the difference between a encoder and a demultiplexer. And it is quite obvious. If you can have some memory of demultiplexer, you can have the difference. Now the first and the foremost difference is select lines. In case of demultiplexer there were select lines, but in case of encoder we don't have any kind of select lines. So that is the most important difference between encoder and demultiplexer. Now if I will tell you about the similarity, what is the similarity between encoder and demultiplexer? Just comment in the comment box. So the one thing we can have the obvious answer there, we are having one input, many output. Here in case of encoder also we are giving one symbol as the input and we are getting many outputs or binary codes as the outputs. So that is all about the introduction part. So for the definition point of view, the only thing you have to remember that encoder is a combinational circuit that converts a preferred number or symbol into binary codes. Okay, and here also we'll have only one symbol as the input and n number of binary numbers as the output. Now there are various types of encoder present in digital electronics, and depending on that, I mean depending on our syllabus or what we are going to have the knowledge about is we have to focus on these two encoders. The first one is octal to binary encoder, and decimal to binary encoder. It is also known as BCD encoder. Now first we will discuss about this octal to binary encoder. So the definition is quite simple. Octal to binary means the input is octal number and we are converting that into binary number. So it is a digital combinational device that converts octal symbols to binary codes. So any device which converts octal numbers to binary codes are known as octal to binary encoder. Now we'll directly jump to the design. The design process is very simple. We'll try to do it, and we'll first try to analyze and then we'll go for its design. Now in this case, you can have the analysis like this. If I have to go for the block diagram, we can draw it like this. This is the octal number. I mean, I am taking this one point as octal number, okay? And we are taking, if, now one more thing I want to tell it over here. If it is a octal number, can you tell me how many binary numbers are required in order to have the representation of octal number? So we have already discussed previously in the first module that any octal number has to be represented by 3 number of binary codes. So we'll have 3 binary codes. Okay, so this is your first binary code. I am writing that one as B3, this one as B2, and this one as B1. You can have the numbering as B2, B1, B0, no issues with that. I have taken it as B3, B2, and B1. Now this is the design of your octal 2 binary encoder. Okay, now we can have this octal number as any combination. I mean, octal numbers, we know that it starts with 0 and will end at which number? 7. So for this, we have to design a truth table. Now truth table in this case will be somewhat different from what we have done previously. Now in this case, we'll have octal numbers or octal symbols as the input. So I am writing octal symbols, and depending on these octal symbols, we'll have the encoding of binary. So I am writing the outputs as B3, B2, and B1. Okay, now we know that octal symbols, it will definitely start with 0, then it will go to 1, 2, 3, 4, 5, 6, 7. Now octal numbers are 0, 1, 2, 3, 4, 5, 6, 7. Now in order to have the representation, I am representing it as D0, D1, D2, D3, D4, D5, D6, and D7. Okay. Now I have taken D0, D1, D2, D3 so that we can have a proper lining of that one. I mean, 0 cannot be taken as the input. I mean, 0, you cannot have any line. When we are going for a practical design, we'll not be finding out what exactly 0 means. So for that reason, I'm taking that one as D0. I'll take D0 as 0 and I'll have the connection of that one. So for that reason, I'm taking this one as D0. Now if octal number 0 is there, it will be coded in binary. Definitely it will be coded in the form of 0, 0, 0. Okay, 1, it will be coded in the form of 0, 0, 1. And if you are finding out any difficulty that how it is being coded, you just use my concept of 4, 2, 1. Simple coding. D0 means 0, means nothing are getting utilized, so 0, 0, 0. Then 1, only 1 is getting utilized, so I'll have 1. 2, only 2 is getting utilized, so it is 0, 1, 0. 0, 1, 0. 3, so it is 0, 1, 1. 4 is getting utilized, so 1, 0, 0. 5 is 1, 0, 1. 6 is 1, 1, 0. And 7 is 1, 1, 1. So these are your octal symbols, 0, 1, 2, 3, 4, 5, 6, 7. And a line or the data line that is representing 0, 1, 2, 3, 4, 5, 6, 7, I have just written it. And the code, I mean the output, 0 will be coded as 0, 0, 0, 1 will be coded as 0, 0, 1, and likewise 7 will be coded as 1, 1, 1. After having this truth table, we will use and we'll directly go for the design. We'll not have any kind of Boolean expression because we are not using any kind of combinations or anything else. Therefore, we'll directly go for its. The design process is somewhat different than the normal combinational circuit. We'll use at D0, D1, D2, D3, D4, D5, D6, and D7. Okay. Now, in order to find out what is the expression of B3, because we have to design B3, we have to design B2, we have to design B1. So in order to have the Boolean expression for B3, we'll look forward that which of the data lines are active when B3 is taken as the output. So which are the data lines are taken, which are the data lines that are high during B3 encoding or B3 output? So you can clearly see D4 is higher, D5 is higher, D6 is higher, and D7 is higher. So B3 value will come out to be D4, D5, D6, and D7. Okay. Similarly, for B2, you can tell me which data lines are higher: D2, D3, D6, D7. So D2, D3, D6, and D7. And finally, B1. So B1, you can have the values as 1, 3, 5, 7. So it is D1, D3, D5, D7. Okay, so the values where we are getting 1, 1, 1, 1, we are keeping that into account and just putting a plus sign in between. So these are the three values or three binary expression, or you can say Boolean expression, that we have to design. And if we will be able to design this one, we'll be able to design our encoder. Okay, so we'll go one by one and we'll have the design of that one. So for B3, you can clearly visualize it is the summation of D4, D5, D6, D7. So we'll take D4, D5, D6, and D7. Okay, D7, and connect all of them with a which gate? Because it is connected with plus symbol, so we are taking a OR gate over here. Okay, connect all of them with OR gate, and you will get the first output, that is B3. Okay. The next thing is you have to go for B2 design, that is D2, D3, D6, D7. So we'll take D2 from here, D3 from here. Okay. Then this one is your D6. So just I am putting a dot so that you can recognize it easily. D6. And this one is D7. So I am taking this one as D7. Connecting all of them to a OR gate. This one will give you B2 as the output. Okay. Now the final one is your B1. That is the combination that we need to draw is D1 plus D3 plus D5 plus D7. So once again, I'll take D1 from here. Okay. Then D3. I am taking D3 from here. So I'm just putting a dot over here so that we can have a proper realization. Then we'll go for D5. This one is D5, putting a dot. And the last one is D7. I'm putting a dot over here, just taking this line and connecting them with a OR gate. Okay. This is our B1. So this is how you can see this is the design of, and D0 is not getting used. We need not have to write this one. You can remove this one. So D1, D2, D3, D4, D5, D7. You can have the conversion, or you can have the design of octal to binary using this circuit. Okay, where we are having inputs from D1 to D7 and we are having outputs as B3, B2 and B1. So this is all about the octal to binary encoder. Once again, I'm just repeating it for your convenience. What we are doing exactly? It is what is octal to binary encoder? It is a digital combinational circuit that converts octal symbol to binary. We are giving octal numbers as the input and it is converting that to binary. We know that any octal number can be represented in binary format by three variables. Therefore, we are taking three outputs, that is B3, B2 and B1. For the truth table, we have taken the octal symbols starting from 0 to 7. And for having a proper realization, we have just numbered 0 to D0 and respectively D7 7 to D7. After that, 0 will be encoded as 0, 0, 0, 1 will be encoded as 0, 0, 1, and likewise we have gone for D7 representation as 1, 1, 1. After having this truth table, we need to find the expression for the output. So for finding the expression for the output, the first thing we need to find out B3. So B3, now you have to look for where the values are equal to 1. So in case of B3, D4 is high, D5 is high, D6 is high, and D7 is high. So therefore, we have just added it in order to get the value of B3. Similarly, for B2, we are having D2, D3, D6, D7, and for B1, it is 1, 3, 5, 7. After having this, we have taken the data lines starting from 1 to 7 and just connected as it is required for B3, B2 and B1. And finally, this is the encoder diagram for octal to binary. Okay. The next topic of discussion is BCD encoder. Okay, I want that all of you should be doing it by yourself. I'll be just giving you some hints in order to have the design of this BCD encoder, or you can say decimal to binary encoder. BCD is nothing but decimal number, and in that case, where the symbol will start, the symbol will start from 0 and it will end at which number? 9. Now we know that BCD numbers are encoded in the form of binary by 4 bits. So we'll take it as B4, B3, B2 and B1, and just go on filling these values depending on the numbering, that is 0000, and it will end definitely at 1001. And after having that, you will once again go for writing the Boolean expression for B4, B3, B2 and B1. Once you have got that one, using OR gate, you will have the design. So I think whatever thing I have explained you have got that how to design the BCD encoder. Just comment in the comment box whether you are able to design the BCD encoder or not. If you are doing it, if you are able to do it, it's fantastic. And if you are not able to do it, write in the comment box. I'll be doing it for you in the next video. Thank you. Thank you very much for joining. If you have any suggestions for improving the videos, it will be highly recommendable. Thank you.